Friends, today I would like to teach you a concept of clocks. So in a clock, basically there are two hands. We want to focus on that. One is hour hand and the other is the minute hand. So what is the speed of minute hand? First of all, the minute hand covers the entire circle, that is 360 degree, in exactly 1 hour, which is 60 minutes. So in other words, the speed of minute hand is 6 degrees per minute in terms of degrees per minute. By the same logic, the speed of hour hand is what? The hour hand covers the entire circle in exactly 12 hours, which is 720 minutes. So therefore, the speed of hour hand is 0.5 degrees per minute. So in other words, the relative speed in them is 5.5 degrees per minute, as it is minus because they are in the same direction, which is called as clockwise direction. Okay, now what we'll do is I'll teach you two important concepts of clock, and then I'll take you to one very good awesome question which has been coming in CAT 2-3 times as well. So the first concept is, I'll write here, between 3 and 4, after what time from 3 p.m. or 3 o'clock, whatever, the hands of the clock meet each other. Between 3 and 4, after what time from 3 p.m. the hands of the clock, that is the hour hand and minute hand, will superimpose, will coincide, will meet each other. This is the question. So if you can visualize, this is 3 p.m. The angle is of course 90 degrees, because in every one division the angle is 30 degrees. Now my question is, after some time from 3, the hour hand will slowly move towards this, the minute hand will follow and come on the top of the hour hand. I want to know after what time, after how many minutes it's going to happen. So there are various ways of doing it. I'll tell you the best method, which is the basic one of relative speed concept. Look at it like this. The minute hand has to cover 90 degree to meet the hour hand. So if I say that the hour hand is stationary, the minute hand will cover 90 degree and it will meet the hour hand. So the time taken to meet is nothing but distance upon speed. The distance to be covered is 90 degree and the speed is 5.5, my dear friends, not 6, which sometimes students take. The logic is, because I am assuming hour hand is stationary, hour hand is actually not stationary. It is also moving with 0.5 degree per minute. So the concept of relative is, the minute hand is taking or rather moving at 5.5 degree per minute extra relative to the hour hand. So if I say that hour hand is stationary or fixed over here, the minute hand has to cover 90 degree at this extra speed, and therefore the time taken to meet is this, which is nothing but your answer. Please understand. After these many minutes, the hour hand and minute hand will be superimposing between 3 and 4. Very good question. So can anyone tell me, between 4 and 5, what would be the answer? This answer is between 3 and 4. Between 4 and 5, what would be the answer? After what time, between 4 and 5, the hands of the clock will meet each other? Well, I am sure all of you have understood. The answer is nothing but 120 upon 5.5 minutes, my dear friends. Why? Because at exact 4 p.m., the angle which the minute hand has to cover is 120 degrees. So this time, this is the distance, this is the speed. So 120 upon 5.5. Between 5 and 6, what is the answer? 150 upon 5.5. Between any x and x plus 1, what is the answer? The answer is 30x divided by 5.5, because at every division 30-degree angle is increasing. Okay, so this is first. Let me rub everything and I will ask you second question. Okay, the second type question in clock is this. Find the angle between the hands of the clock at 3:40. Let me write it a little bigger for you guys. At 3:40, what is the angle between the hands of the clock? So I have seen students doing in various ways. You know, they move the minute hand by 40 and hour hand 2/3 of 40 by 60 and so on. Forget it. I'll tell you the best method. Now what you do is make a circle like this. This is 3 p.m. and this is 8. You know, because 5 8 is 40. Now at 3 p.m. exact the angle is 90 degrees. We want to find this angle. Again apply the same logic. Assume the hour hand is stationary at this point. The minute hand actually moves from this position till the 8 number position. Let the hour hand be here only. So in the entire time, 40 minutes have passed. So in 40 minutes, the minute hand have moved by the angle 40 into 5.5. How? This is the time, this is the speed. Speed into time is the distance traveled in degrees. So this entire angle, my dear friends, this entire angle, you know, this entire angle is what? 40 into 5.5. What do I want to know? I want to find this angle. So what will I do? I will subtract from this entire angle the original angle at 3 p.m. which is nothing but 90 degrees. And you know what? This is the final answer. This is awesome method. 40 into 5.5 is the total distance traveled by the minute hand, the total angle. If I subtract the original angle between them, I get this angle. Because I have applied 5.5 and I am actually taking the relative speed of them. So if I assume the R hand is here, R hand is actually not here, it is moving. But it is taken care when we took the speed as 5.5 of the minute hand. This is the concept of relative speed. So 40 into 5.5 minus 90, you will directly get your answer. I think it is 130 degrees. 220 minus 90. Okay, anyways, 450. Come on guys, what is the angle at 450? Try and apply the same logic. 5 seconds. You will directly get it very fast. The answer is 50 into 5.5 minus 120. Because at exact 4 p.m. the angle is 120 degrees. 30 into 4. So I am sure you have understood, but just to give you a capsule. What is the angle at x, y? As in x bachkar y minute, we call it like that. What is the angle at x, y? X dot y. The answer is y into 5.5 minus 30x, and please take the mod of this because this might be lesser. For all you know, this is your answer. Direct concept of question of clock. Find the angle between the clocks at whatever time. Okay, so this is second type question. Now what I would like to ask you is an awesome question in clock which has been coming in the various important exams like CAT and XAT. The question is like this. A man goes out from his home between 5 and 6. This is given. He goes out between 5 and 6 and comes back between 6 and 7. The man goes out from his home sometime between 5 and 6 and he comes back sometime between 6 and 7. Now what happens is, the moment he comes, he saw the clock and he saw that the hour hand and minute hand have exactly changed their earlier positions. Are you able to follow? So if you can visualize, this is 5, this is 6, this is 7. So the man must have gone somewhere between 5 and 6. He came between 6 and 7 and he found that the hour hand and minute hand have just completely changed their positions. Earlier, wherever there was hour hand, now exactly that is the minute hand, and earlier where there was minute hand, now exactly is the hour hand. My question is, for how much time T, for how much time he was out? For how much time he was out? This is the question. So how to solve it? Okay. Let me make a figure for you so that you can probably understand. Now what I say is, since he has gone between 5 and 6 and come back between 6 and 7, what is actually happening is that the earlier minute hand must be somewhere here and earlier hour hand must be somewhere here. You know, and then they have interchanged the position. So this is between 5 and 6, this is 6 and 7, and came back, something like this has happened. This is the hour hand now, this is the minute hand, new one. Now I'll tell you something. Let's say this angle between them is theta. Okay, how to solve it? How to find the time? Now pay attention. Let's say the man has gone out for T time. So in T time, let us see what is this minute hand going to travel. This is the minute hand. The minute hand will travel in T time from here to here. Because the minute hand came exactly at where the hour hand was earlier. So can anyone tell me what is this degree? How much degree the minute hand has travelled in time T? It has travelled 6 into T degrees. Because the speed of minute hand, I am talking in absolute terms this time. The speed of minute hand is 6 degrees per minute. So in T time, it will travel 6 into T. This is a total degree, this one. Okay, plus, in the exactly T time, the hour hand has moved from this position. Let me give the names for your understanding. From AB to AC. The hour hand has moved from AB to AC. So, in that time, it has moved 0.5 into T. Please understand, because this is the speed of hour hand, into time will give you this degree. And this is this much theta degree. So, if I add both of them, what I should get, my dear friends, if I add this, can you visualize this entire thing plus this? How much degree it is? It is obviously 360 degrees. And solving T is nothing but 360 upon 6.5, which is nothing but 720 upon 13 minutes. Answer. So for this much time, the man was out. This is an awesome concept. I have seen a similar question in ZAT, in which they said a man goes between 5 and 6 and came back between 8 and 9. So for how long period he was out? So here, since the duration is 1 hour, we did 360 by 6.5. If it is 5 and 6 and 8 and 9, basically it's a 3 hour period. So what's the answer? 360 into 3 divided by 6.5. Because 360 degree twice he will as travel. So the total angle to be covered is 360 into 3 divided by 6.5. I hope this theory of clocks help you in solving the clock questions, which definitely come in the MBA entrance exams. Thank you.